Picture Italy, 1608. In a small town called Faenza, a future genius is born. Evangelista Torricelli. His family wasn't rich, but young Evangelista had a huge appetite for learning. His uncle, a clergyman, saw his potential and took him under his wing, guiding his education and fueling his love for math and philosophy. This early support sparked something in Torricelli, setting him on a path to greatness. From the schools of Faenza to the prestigious Collegio Romano in Rome, Torricelli's mind thrived. He studied the works of Archimedes and Euclid and explored the revolutionary ideas of Galileo Galilei, his imagination fired up by the possibilities of science. In 1641, Torricelli's life took a big turn. He wrote to Galileo Galilei, the famous astronomer and physicist, expressing his admiration and sharing his own smart ideas about mechanics. Galileo, impressed, invited him to his villa in Arcetri. This meeting led to an amazing partnership. For months, Torricelli worked as Galileo's assistant, learning his experimental methods and his strict scientific approach. When Galileo died in 1642, it left a big hole in the science world. But Torricelli was ready to take the lead. He was named court mathematician and philosopher to Grand Duke Ferdinando II de' Medici of Tuscany, a sign of his growing fame. He kept up his research, talking with other leading thinkers of his time. His star was rising. Torricelli's name is forever linked to a game-changing invention, the barometer. This device revealed a hidden truth. The air has weight. It all started with a simple question. What keeps liquid in a tube even when the top is sealed? Inspired by Galileo's work on vacuums, Torricelli set up an experiment. He took a glass tube, sealed one end and filled it with mercury. He then flipped the tube upside down into a dish of mercury. The mercury level went down, but not all the way. It stopped at a certain height, leaving an empty space above. Torricelli realized this wasn't just air, it was a vacuum. An idea that challenged the popular belief that nature hates empty space. He figured out that the weight of the air pushing down on the mercury in the dish was holding up the mercury in the tube. The height of the mercury column then showed how much air pressure there was. Torricelli wasn't just interested in air pressure, he was fascinated by how liquids move, their flow controlled by invisible forces. He wanted to understand the rules of this liquid dance. Through careful watching and experiments, Torricelli made a big discovery. He noticed that the speed of liquid flowing out of a hole wasn't random. It depended on how high the liquid was above the hole. Higher liquid, faster flow. This discovery is now known as Torricelli's law. It's a key principle in fluid dynamics, used for everything from designing fountains to understanding blood flow in our bodies. Torricelli's law isn't just a simple observation, it's a precise mathematical formula. It says the speed of liquid coming out of a hole is related to the square root of the height of the liquid above it. This formula, V equals the square root of 2gh, where V is velocity, g is gravity, and h is the height, is a cornerstone of fluid mechanics. It helps engineers predict and control liquid flow really well. Torricelli's law is used in designing pipelines, dams, and irrigation systems. It helps us understand how blood flows in our bodies. It shows the power of observation, experiments, and math. While Torricelli's work on fluids changed our understanding of the physical world, his math work explored the idea of infinity. He was interested in infinitesimals, super tiny numbers that help us understand curves, tangents, and areas. Torricelli's work paved the way for integral and differential calculus. He developed ways to calculate the area under curves and the slopes of tangents, using infinitesimals as his tools. His work came before the famous work of Isaac Newton and Gottfried Wilhelm Leibniz, who developed calculus into a powerful math system. Still, Torricelli's contribution to this important area of math is significant. Torricelli's curiosity led him to explore the weird world of solids of revolution. These are 3D shapes made by spinning a 2D curve. He was especially interested in a strange idea, shapes with a limited volume but an unlimited surface area. He showed this mind-bending idea with a shape made by spinning a hyperbola called Gabriel's horn or Torricelli's trumpet. It has a limited volume but an endless surface area. This surprising result challenges how we think about infinity and dimensions. It shows how math can reveal hidden truths about the universe. Sadly, Torricelli died young in 1647 at age 39 from typhoid fever. But his scientific work is huge and lasting. His legacy is a part of modern science. The barometer, his most famous invention, changed meteorology, giving us a way to measure air pressure and predict weather better. His work on fluid dynamics, especially Torricelli's law, is the basis for how we understand liquids. This knowledge is crucial for designing things like irrigation systems and even airplanes. His math work, especially with calculus, helped create one of the most powerful tools in math and science. Torricelli's story shows the power of curiosity, observation, and the drive to learn. He started with a desire to understand the world and ended up making amazing discoveries that changed how we see the universe. Torricelli's legacy is more than just his inventions. His scientific approach, careful observation, strict experiments, and using math still inspires scientists and mathematicians today. His life reminds us that searching for knowledge is a great thing. Every question we ask, every experiment we do, and every math problem we solve brings us closer to understanding the mysteries of the universe. Torricelli's spirit of discovery lives on in every scientist who asks why, and every student who looks at the world with wonder and curiosity.